Welcome to this video tutorial where I will guide you step by step on how to create a frequency distribution table for group data. But before we start, what is a frequency distribution table? A frequency distribution table is a tool to organize data into groups or intervals to make it easier to analyze. It shows how often each group or range of values occurs in a dataset, helping us spot patterns or trends more clearly. It's especially useful when working with large amount of data. We will follow 14 simple steps to follow and I will guide you through each one. Let's get started. Let's say that this is your raw data. The first thing that you have to do is to arrange the array. You have to put the highest value to the lowest to make it easier to analyze. After arranging the array, the next step is to count the total number of data points and we'll refer to it as the n. For our third step, we have to compute for range. Now, to calculate the range, we just have to subtract the highest value to the lowest value. 78 minus 48 is going to be 30. For step number 4, we calculate the k, which represent the number of classes. To do this, we will use Sturge's rule. The formula is 1 plus 3.322 log n. The n is the total number of data points. First, take the logarithm of n, then multiply it by 3.322 and finally add 1 to get the value of k. And our value of k is going to be 6.32 or 6. Step number 5. Identify the class interval. For this, it's going to be simple. All you have to do is divide the range and the k and you will get the answer, which is 30 divided by 6 is 5. And for our sixth step, which is number of classes, all you have to do is divide your range and your interval and you will get the answer of 6. After getting all the value, we can now create our table. Now, let's create our classes interval. Start with the highest value from your dataset. For example is the value of 78. We can set our first class interval to 78 to 74. Then to create the next interval, we just have to subtract the width from the lower limits to the previous interval. We just have to keep subtracting the class width until you cover all your data. For step number 8, we just have to count how many values fall into each class and record the frequencies. Step number 9 is to identify the class mark. In here, we just have to add the lower limits plus the upper limits and divide it by 2. For example, is 78 plus 74 and divide it by 2 and we will get the answer of 76. We just have to repeat it again after all data is covered. And for our step number 10, we have to calculate for the cumulative frequency. To calculate the less than cumulative frequency, we just have to add the frequency from the first interval up to the current interval. And you just have to repeat the process until it's all covered. For our greater than cumulative frequency, You just have to do the opposite direction. Add the frequency from the last interval up to the current interval. Starting from the last class interval and moving backward, you add each frequency to get the greater than cumulative frequency. For step number 11, we have to identify the lower and the upper limits. For the lower limits, it is the smallest value in the class interval. And for the upper limits, it is the largest value in the class interval. You just have to write the highest and the lowest. For our step number 12 is we have to identify the lower and the upper boundaries. For the lower boundaries, we just have to minus our lower limits to 0.5. For example is 74 minus 0.5 equals to 73.5. Next lower limits is 69 minus 0.5 is equal to 68.5. And we just have to continue so on until it's all covered. On the other hand, for our upper boundaries, we just had to plus the upper limits to 0.5. So 78 plus 0.5 is equal to 78.5 and so on. For our step number 13, we have to compute for our relative frequency. To compute for this, we just have to divide the frequency of the class to the total number of the class. 7 divided by 40 is equal to 0.175. Next is 6 divided by 40 is equal to 0.15. 4 divided by 40 is equal to 0.1. 11 divided by 40 is equal to 0.275 and so on. For our step number 14 is to compute for percentage. Let's look how to convert relative frequency into percentage. Our formula is relative frequency times 100. For example, 1.75 rather times 100 is equal to 17.5. Next, 0.15 times 100 is equal to 15. 0.10 equals to 100 is 10. 0.275 times 100 is equal to 27.5 and so on. And there you are, you completed your group frequency distribution table. And that's it. We have gone through all the steps to create a complete frequency distribution table. I hope this video made the process easier for you to understand. Remember, organizing data in a table helps you see a pattern and analyze information more effectively. If you have any question or need more help, feel free to leave a comment below. See you next time! Hello everyone, welcome to this video tutorial where I will guide you step by step on how to create a frequency distribution table. We will follow 14 simple steps to follow and I will guide you through each one. Let's get started. The first thing that you have to do is to arrange the array. To arrange the array, you have to put the highest value to the lowest to make it easier to analyze. After arranging the array, the next step is to count the total number of data points, which is 40. And we will refer to it as the n. For our third step, we have to compute for range. Now, to calculate the range, we just have to subtract the highest value to the lowest value. "89 minus 65 is going to be 24. And there we have it. That will be our range. For step number 4, we just have to calculate the k, which represent the number of classes. To do this, we will use the Sturge rule. The formula is 1 plus 3.322 log n. The n is the total number of data points. First, take the logarithm of n and multiply it by 3.322. And finally, add 1 to get the value of k. One plus 5.32 is equal to 6.32 rather, and that will be our value of k. For the step number 5, we have to identify the class interval. For this, it's going to be simple. All you have to do is divide the range and the k, and you will get the range divided by k, which is 24 divided by 6.32 is going to be equal to 4. For our sixth step, which is the number of classes, all you have to do is divide your range and your interval. "24 divided by 4 is equal to 6. After getting all the value, we can now create our table. Now, let's create our classes interval. Start with the highest value from your dataset. For example, is the 89 to 86, 85 to 82. We just have to subtract the width from the lower limits to the previous interval. We just have to keep subtracting the class width until you cover all your data. For step number 8, we just have to count how many values falls into each classes and record the frequency. Just simple as that. For the step number 9 is to identify the class mark. In here, we just have to add the lower limits plus the upper limits and divide it by 2. And we just have to repeat it again and again and again until our all data is covered. For the step number 10, we have to calculate for the cumulative frequency. To calculate the less than cumulative frequency, we just have to add the frequency from the first interval up to the current interval. And you just have to repeat the process until it's all covered. And for our greater than cumulative frequency, you just have to do the opposite direction. Add the frequency to the last interval up to the current interval. Starting from the last class interval and moving backward, you add each frequency to get the greater than cumulative frequency. For the step number 11, we have to identify the lower and the upper limits. For the lower limits, it is the smallest value in the class interval, and for the higher limits, upper limits rather, it is the largest value in the class interval. You just have to write it, the highest and the lowest. Simple as that. Step number 12 is we have to identify the lower and the upper boundaries. For the lower boundaries, we just have to minus our lower limits to 0.5. And we just have to continue so on until it's all covered. On the other hand, for our upper boundaries, we just have to plus the upper limits to 0.5. For our step number 13, we have to compute for our relative frequency. To compute for this, we just have to divide the frequency of the class to the total number of the classes. Remember that our total number is 40. 6 divided by 40 is equal to 0.15. 0.15, 13 divided by 40 is 0.325, and you have to repeat the process until it's all covered. Our last and 14th step is to compute for percentage. Let's look how to convert relative frequency into percentage. Our formula is to times it to 100, our relative frequency. So 0.15 times 100 is equal to 15. 0.325 times 100 is 32.5, and you have to repeat it until you get all the value. And that's it. We have gone through all the steps to create a complete frequency distribution table. I hope this video made the process easier for you to understand. Remember, organizing data in a table helps you analyze pattern information more effectively. Thank you.
Creating a group frequency distribution table in SPSS. First step, assign a variable name for your data. Next step, add a label and set it to scale. Next step, copy and paste your raw data from Excel into SPSS. Now, go to Transform, select the visual binning, then select the respondent's math score variable and move it to the Variables to Bin section. Now, click Continue. Next step, click bin variable, assign a variable name, and click make cut points. Enter the lowest score in first cut point location. Now, set the number of cut points to 5, which is the class intervals. The width will be calculated automatically. Now, check excluded and the make labels, then click OK. Now, we have a new variable with bin values is now created. To generate the frequency table, go to Analyze, select the descriptive statistics, frequencies, add the bin variable to the variable box. Check the option to display the frequency table and click OK. Now, we have a group frequency distribution table and PSS.
Good day everyone, I am Bainos from Mazarisao University, taking up a BS Psychology course. Today, I am going to teach you how to create or do an ungrouped frequency distribution table or FDT in a manual way. When we say manual way, we do it on paper and with the use of calculator. But first, let's discuss how important frequency distribution table in the BS Psychology course. An ungrouped frequency distribution table is important in a BS Psychology course as it is the first step in understanding data and serves as the basis for the advanced statistical analysis. It provides a clear, organized view of raw data and it helps develop essential skills in descriptive statistics, data visualization, and hypothesis testing. For psychology students, mastering these basic tools is crucial for interpreting research findings, analyzing behavioral data, and preparing for more advanced coursework in statistical methods. Now, let me show you the step-by-step procedure on how to do an ungrouped FDT. Now that we have a set of data, first is we need to list our raw data. Second is we sort our raw data into ascending or descending. Sorting is optional but it may help you a lot in identifying your frequency. Third is to identify the unique data value. Fourth is to identify the frequency of each data by identifying how many times each of your data appeared in raw data. Fifth is to create the frequency distribution table. Sixth step is to calculate the less than cumulative frequency by adding your frequency from the top. Seventh step is to compute the greater than cumulative frequency by adding your frequency from the bottom. For the RF. To get the RF, you divide the total or sum of the frequency to each of your frequencies. For example, 1 divided by 30 is equals to 0.03. For the ninth step is to calculate for the less than relative cumulative frequency by adding your RF starting from the top to the bottom. To compute for greater than relative frequency by adding your RF from the bottom to the top. Last step is to compute for our percentage, which is you multiply your RF to 100. For example, is 0.03 multiplied by 100 is equals to 3. So your percentage is 3%. You could just continue to multiply each RF into 100 to get each percentage. And after that, you add all the percentage and it should be equal to 100.
Good day, everyone. Today I am here to show you how to create a ungrouped data for our frequency distribution table by using Excel. This is especially useful when you're dealing with raw data and want to summarize it into a frequency table. So first, of course, I will need to start with a blank workbook. But I will just copy this so that we won't waste any time. Okay, we have our statement. Assume these represent the scores on the psychological test measuring stress level on a scale of 1 to 10. And this is our raw data. Shift down to copy it. Control plus copy. Control plus V for it to paste. For our array, we need to make it ascending to descending or descending to ascending. Let's make another one. So for us to achieve the descending or ascending to descending, we need to highlight the raw data, go to data, click sort. For the sort warning, you need to choose the continue with the current selection, then click sort. Here we can find the order. which have the smallest to largest, largest to smallest, and custom list. If you want smallest to largest, the ascending to ascending, click smallest to largest. If you want it the ascending to descending, click largest to smallest. I want it to be as the ascending to ascending, so I will click the smallest to largest, then click OK. Now we can see the array that is descending to ascending. Okay, FDT. What does FDT mean? Frequency distribution table is a statistical tool that organizes data by showing how often each value or range of values appears in a data set, especially listing each category and the number of time it occurs, providing a summary of the data distribution within a set of observation. It typically consists of two columns, one listing the categories or values, and the other showing their corresponding frequencies. This is the part of the column for our FDT. X is scores, which will come from our raw data. F is the frequency, the number of times the raw data is there. CF, cumulative frequency. RF, relative frequency. RCF, relative cumulative frequency. And the last one is total. Today what I'm going to show you is the ungrouped data. Let's put it X, XF, CF, RF, RCF, RCF, and and the total. So we will put our raw data here in our score, which we have 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. 2, 3, 4, 5, 6, 7, 8, 9, and 10. To get our frequency, we just need to count how many are there in the raw data. For example, number sa scores natin na number 2, meron lang tayong isa. Sa score naman natin na number 3, meron tayong 3. Sa scores naman natin na 4, meron tayong 3 rin. Sa scores natin na 5, meron tayong 4. Sa scores naman natin na 6, meron tayong 6. Sa scores natin na 5, sa scores natin na 7, meron tayong 5. Sa scores natin na 8, meron tayong 3, pati sa 9. Sa scores naman natin na sa 10, meron tayong 2. In data in the frequency. Okay, may nasawa. Okay, let's explain how to get the less than cumulative frequency. To get the less than cumulative frequency, the first one, we need to get that sa una nating frequency, which is number 1. Sa pangalawa nating cumulative frequency, we can get that by adding the first CF and the second frequency. This is what we should do para mas mapadali natin yung pagkuha niyan. Equals, close parenthesis, click the L43 plus, click the K44, close parenthesis, enter. Para mas mapadali pa natin, click equal, close parenthesis, click L44 plus K45, close parenthesis, then kunin mo siya pababa. Then, makikita natin na may sum tayo na 30. Our n is 30. That is the equal of the raw data that we have, decimation. Sa CF naman, sa greater than CF, ganun rin siya, babalik rin lang natin. Magsisimula na naman tayo sa baba ng frequency, which is number 2. Makukuha natin yung pangalawa sa pinakababang CF by adding the last frequency at yung second to the last frequency. Okay. 2 M51 plus K50, enter. Okay, lagyan natin siya ng linya para mas madaling maintindihan. Balik tayo sa less than CF. So, to get the first CF, you just need to put the frequency, the first frequency that we have. To get the second one, add the first CF to the second frequency to get the second CF. At magtutuloy-tuloy yan hanggang sa matapos ka, hanggang sa baba. Same na rin siya for our greater than, pataas nga lang ha. Okay, 2 plus 3 is equals to 5 for our second to the last greater than CF. Ganun lang siya, pataas lang siya. Kabaliktaran nga lang siya ng less than CF. So for our RF, we have a formula for that. RF is equals to F divide N. Our N is 30. So, ang mangyayari equals, close parenthesis, 1, the first frequency, divide 30, close parenthesis, enter. That is our RF now. Gawin lang natin ulit siya. So for our second relative frequency, we have 3 divide 30, close parenthesis, enter. Okay. We are on our last two. Last one. Okay. Divide. Okay. So, gawin natin siya lahat na naka 2 decimals. Gawin natin siyang 2 decimals. Okay. So, for our RCF, ang mangyayari lang rin is katulad ng method sa pagkuha ng less than CF. Pero ang kaibahan, kukunin natin siya dito sa relative frequency. So our first RCF less than RCF is the first RF, which is 0.03. Zero point zero three plus 0.10 is equals to our second less than RCF. Okay. To get that equals, click the first less than RCF plus the second RF. Lalabas na yung equal sa atin dyan. Okay, ganun lang rin siya sa CF. Pero para mas mapadali natin yung pagkuha, equals tayo. Close parenthesis, click the second less than RCF plus the third RF. Close parenthesis, ibaba natin yung nakuha natin. So, equals 1.00 siya. Dapat ang lalabas dyan 1.00. Kasi kung hindi, ibig sabihin, nagkamali ka ng computation sa mga nauna. Ganun rin naman sa greater than RCF. Katulad lang rin ng method ng less than CF. So, to get that, kukunin natin yung nasa babang RF, which is 0.07. To get the second to the least greater than RCF, we just need to add the last greater than RCF to the second to the last RF, which is 0.10. Okay. Enter. And gagawin nyo lang siya pataas until makakuha kayo ng 1.00. Okay, for our last one, equals, close parenthesis, the second greater than RCF plus the first, okay, plus the first RF, which is 0.03, close parenthesis, enter, and that will result to 1.00. Our total, we also have a formula for that, which is RF times 100. RF times 100. Enter. Oh, is 3.33 times 100, close parenthesis, enter. Try nating ibaba siya kung susundan niya yung una kong ginawa. RF 0.10 times 100, close parenthesis, ibaba natin siya. Okay, nakuha rin natin siya. So, to verify if tama siya yung computation natin, we can use equals SUM, close parenthesis, highlight the totals, close parenthesis again, and enter. So, tama yung computation natin dahil nag-equal siya ng 100. Okay, so may mean median mode naman tayo. This is the formula for our ungroup mean. Para makuha natin yung mean, pag-a-add natin tong ating raw data. Okay, just need to highlight this. To highlight the raw data. Oh, before that, equals sum, close parenthesis, and highlight the raw data. And close parenthesis again. And that is our sum. To get the media, we just need to follow the formula 30, which is our sum, plus 1 is equals to 31. 31 divided by 2 is 15.5. Okay. Which is 15.5. Hanapin lang natin yung pang 15 na number sa raw data. Let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 6 as our median. Sa mode, yan yung kung ano yung pinakamalaking number dito sa frequency, yun ang ating mode. Kasi yun yung pinakamaraming number sa ating raw data, which is 6. Okay. Equals to 6. Now, our mean is 185. Our median is 6. And our mode is 6. Okay, may nakalimutan ako sa median. 185 ang lalabas, di ba? Sa ating mean, pag pinagsama-sama mo lahat ng ating raw data. After that, 185 divide 30 is equals to sa ating mean, papalitan natin siyang yung 185 na 6.2. So that is all for our discussion on how to do a frequency distribution table and group data on Excel, the same as the mean, median, and mode. Thank you for listening.
Hi, greetings to everyone. I am Alan Obrador, a member of Group 1. I will teach you a simple method of creating a frequency distribution table of ungrouped data in SPSS. First, we gather the ungrouped data and put it in the table in the data view area. Below, as seen here, there are two, the data view and the variable view. Since I have the raw data here, the next thing we do is to click the variable view. As you can see, there is a name there. Change it into stress level since our raw data is from stress level. And for the following one, we notice that there is a word type there. That is the variable type, as well as a word numeric under the variable type, which is one of the variable kinds. When we click it, there is a different sorts of variable available there. Now we notice that there is a numeric variable. Click it and then check for the decimals. Since we will not be utilizing decimals, click down the arrow and set it to 0, and we're done. And after we converted it to numerical variable, we will go on the measurement. Because we see that it is unknown, click it and see that there are three metrics available: the scale, ordinal, and the nominal. Since we went in the scale measurement, we will click it and done. So to examine the data in the upper section on your SPSS, click Analyze. We can see that there are several contents available. Therefore, we will choose the descriptive statistics and select frequencies. Then click the respondent stress level ratings. And then you can also add there, click the statistics and click the mean, median, and mode. And click continue. And finally, click OK. As you can see, using SPSS make it simple to understand the frequency distribution table and takes less time than the manual calculating. As you can see there, that's it. It's so easy and simple to make the frequency distribution table, the mean, median, and mode using the SPSS. Here we go. That's it. I hope you learned anything from me about how the frequency distribution table using SPSS. Thank you.